A few days ago, Microsoft announced a new mode for GitHub Copilot, Agent Mode, which significantly simplifies work for developers who have been using GitHub Copilot. As mentioned in the article, GitHub Copilot Agent Mode can analyze its own code, detect errors, and fix them automatically. Moreover, it can also suggest terminal commands and request their execution. Additionally, it automatically analyzes problems during program execution and has the ability to self-heal by fixing these errors. In Agent Mode, Copilot not only iterates through its own output, but also through the results of that output. This way, it will continue iterating until it completes the entire task, performing all subtasks necessary to fulfill our prompt. Instead of only performing tasks that we explicitly specify for Copilot, it now has the ability to deduce what additional tasks should be performed to fully complete our task. Furthermore, in Agent Mode, Copilot can catch its own errors, saving us from manually copying and pasting back into the terminal from chat. In this video, we'll see how to use GitHub Copilot in Agent Mode, comparing it to the previous version where we used GitHub Copilot edits in chat. If you're new to the channel, make sure to subscribe. But before we dive into GitHub Copilot Agent, we'll look at a sample project and how we could use GitHub Copilot until now without Agent Mode, and then compare it to the new approach using the agent. The project we'll be testing Copilot on is an application built with ASP.NET MVC, which includes both front-end and back-end code. The entire solution follows clean architecture, and from a user's perspective, it allows account registration, login, and managing car repair shops. You can browse them, create new ones, and edit those that the user has created. I should mention that this application was created as part of my ASP.NET MVC course, which you can find linked in the description. Let's say in this example we want to add the ability to delete a car repair shop by the user who created it. This functionality involves, first of all, on the front end, in the tab that displays the list of all car repair shops, we should have an additional button that allows deleting a specific repair shop if the logged-in user is the one who created it. And secondly, clicking this button should trigger a specific action in our controller. Moreover, since the entire application uses clean architecture, I want the controller itself to contain no logic, with all the logic being in the appropriate command handler. So for this purpose, I'll open a new Copilot window and immediately paste the specific prompt I've prepared, asking Copilot to add this car repair shop deletion capability, specifying what Copilot should do. Add a new endpoint and a button directly in the UI that will execute this endpoint. Additionally, Copilot should create a new file with the command and its handler, hopefully doing this properly based on the files I'm about to add to the context. So now, for this function to be properly added to our project, we need to prepare the context properly for Copilot to know which classes to modify and which classes to use as templates to correctly implement the car repair shop deletion function, ensuring that only the user who created the shop can delete it. So let's go to our solution, and now to properly add files to Copilot's context, we can start with the car workshop controller file, simply dragging and dropping it into the Copilot window. As we can see now, this file will be automatically included in the context of our Copilot query. Of course, besides the controller itself, we also need to add the index.cshtml file, where Copilot should add the button to the UI. And of course, for Copilot to properly implement our new command, we can use an existing one, specifically the command for editing a car repair shop, since it already contains the logic to check if a user is the creator of the repair shop. And this is exactly how Copilot should implement the function that allows users to delete car repair shops. So I'll add this file to Copilot's context as well. Furthermore, since our command handlers operate on the repository, both the repository interface should be extended with a function that will delete a specific car repair shop, as well as the implementation of this interface, the specific class. I'll add to Copilot's context window. So I hope that with all this context, Copilot will be able to create the new function in our project that we asked for in this prompt. So let's send this query and see after a moment if Copilot can handle this task. As we can see with this query, instead of implementing changes in our solution, Copilot proposed the structure of this approach, as it didn't fully understand my intention. Now, to force it to work on our workspace, I can simply send the entire prompt again, but this time adding the word workspace as part of the query. This way, Copilot should use the existing files and modify them appropriately according to our needs. And this time in response, we have the appropriate files with our new query command. We have the command handler file, which appropriately uses the user context to check if the user created the specific car repair shop. If so, it will be deleted, and furthermore, we also have the extension of the car workshop repository interface, as well as the implementation of the delete method. We also have the controller update, where a new action called delete has been added, properly handling the encoded name value for the specific car repair shop. Moreover, everything has also been extended to the front end. Specifically, we have an HTML code snippet that will add a new button for deleting a car repair shop. At first glance, the code looks correct, but of course we can implement it step by step. After implementing these changes, let's open our front end and, as a user, create a new car repair shop. After creating such a car repair shop, as we can see in the interface, we now have an additional red delete button, so let's try to use it. As we can see after a moment, the car repair shop was successfully deleted. So we can consider that Copilot handled this very well, adding new functions to our application that required changes in both the user interface and backend, integrating everything through appropriate HTTP requests. Now let's see, with the same example, how we can use GitHub Copilot in agent mode to do exactly the same thing that we previously did in regular Copilot edits mode. Before we move to agent mode, it's worth mentioning that it's only available in Visual Studio Code Insider's version, which needs to be installed separately alongside Visual Studio Code. In the future, it should be integrated into regular Visual Studio Code as well. After installing Visual Studio Code Insiders, we also need to enable it by going to Settings and simply typing Copilot Agent. Make sure you have this option checked, and only then in the Copilot Edits tab, you should have the option to choose between regular edit mode and agent mode, which I already have activated. So being in the same repository, we'll send exactly the same command as a prompt again, and we'll see how after a moment, GitHub Copilot will be able to analyze without context which files need to be changed, what implementations to introduce in specific classes. We'll see if the solution will be just as good as before, without first having to specify the context, and second, without checking changes for compilation errors, as GitHub Copilot agent should be able to figure this out on its own and properly update all necessary classes for this new functionality. As we can see, Copilot first started by reviewing the code and its structure, and moreover, found the controller where the new endpoint should be added, and in the first step added a new class that would delete a specific car repair shop and its handler. And only later did it modify the controller where these new endpoints should be added, and at the very end added a button for deleting car repair shops directly in the index.html file. And it appropriately updated the repository interfaces as well as the specific implementation of the car workshop repository class. Furthermore, it also added a notification after deletion of a car repair shop to provide feedback directly to the user. So overall we have a summary here, and we can now go through each file or each class individually and properly check if indeed the command created by the Copilot agent looks correct. And in this case, we'll be deleting a car repair shop based on its encoded name value, so that checks out. Moving on to the class that actually defines this logic, as we can see again, we have an implementation that will check if the car repair shop we're trying to delete is being deleted by the user who created it. So only in this case will it be properly deleted from our database. So this part looks correct as well. In the controller, if we look at what change was introduced by the Copilot agent, again here we simply, based on the encoded name value that will be contained in this request, will send such a command through the mediator, and furthermore will return feedback to the application user through a mechanism that was already being used in this controller. Let's also check if in the index.cshtml file the endpoint was properly connected. And indeed, here we have first and foremost the action as delete. We have the encoded name parameter with the value of a specific car repair shop from the encoded name property. And furthermore, we also have a simple confirmation above this delete button. So overall, this agent implementation is just as good, if not better than the previous one, where we had to iterate and fix errors that weren't detected earlier by the regular edit mode of GitHub Copilot. So now we just need to accept everything, and all changes have been automatically added to our source code. We could still review them additionally in the Git Changes tab, and that's where all classes and all modifications were introduced by the Copilot agent. Furthermore, if I wanted to run this application, I can also use the agent here, for example by typing the prompt start application instead of manually typing the .NET run command. As we can see here, Copilot detected which specific folder and what command we need to execute to run this application without manual checking. So just click Continue at the top, and as we can see, we've encountered an error, which was also detected by the agent. This time we need to first navigate to the folder containing the application, so again we can click Continue at the top. As we can see, after a moment, the agent executed the .NET run command with our consent, but now we're getting an error message, since in this solution we have several projects. As we can see, it was able to check which specific project should be run, and this time we have the .NET run command with the project parameter with the path to the MVC project. So as we can see, finally we managed to properly run the project using the agent, which was able to interactively check its errors directly in the terminal. As we can see, the application has now been properly launched and is available on localhost, started by the agent,